The device is used on the line side to prove the voltage has been removed. The ChekVolt voltage tester is a device used to verify the absence of voltage in electrical circuits. It is designed to be used on the line side of the circuit, which is the side that is connected to the power source. This allows the user to confirm that the circuit is safe to work on before performing any maintenance or repairs. The ChekVolt voltage tester works by using a capacitor to store a small amount of charge. When the tester is brought into contact with a live circuit, the capacitor becomes charged. The amount of charge that is stored in the capacitor is proportional to the voltage of the circuit. When the tester is then removed from the circuit, the capacitor discharges through the tester's internal circuitry, causing the tester's LED indicator to light up. The ChekVolt voltage tester is a valuable safety tool that can help to prevent electrical accidents. It is easy to use and can be used to quickly and easily verify the absence of voltage in a circuit. Here are some of the benefits of using the ChekVolt voltage tester. Firstly, it is easy to use and does not require any special training. Secondly, it is a non-contact tester, so it does not need to be connected to the circuit to work. Thirdly, it is a compact and portable device, so it can be easily carried around in a tool bag. Fourthly, it is a durable device that is built to last. If you are working on electrical circuits, it is important to use a voltage tester to verify the absence of voltage before performing any work. The ChekVolt voltage tester is a safe and effective way to do this. It is important to understand the function and use of a voltage tester like the ChekVolt in ensuring electrical safety. This type of tester is designed to confirm that a circuit is de-energized before any work is performed, mitigating the risk of electrical shock or arc flash. The ChekVolt operates on the principle of capacitive coupling. When the device is brought near a live conductor, a small amount of current flows into the device's internal capacitor. This current is then processed by the internal circuitry, which in turn provides an indication of the presence or absence of voltage, typically through an LED or an audible signal. Because the ChekVolt is a non-contact tester, it eliminates the need to physically touch the conductors, reducing the potential for accidental contact with live parts. However, it is critical to understand the limitations of non-contact voltage testers. These devices are influenced by factors such as the distance from the conductor, the insulation type, and the presence of grounding paths. Therefore, it is always recommended to verify the readings of a non-contact tester with a known live source before and after testing the circuit in question. This practice ensures that the tester is functioning correctly and that the readings are reliable. Another important consideration is the voltage rating of the tester. The ChekVolt is designed to operate within a specific voltage range. It is essential to select a tester that is rated for the voltage levels present in a circuit being tested. Using a tester with an inadequate voltage rating can result in inaccurate readings or damage to the tester. In addition to verifying the absence of voltage, a voltage tester can also be used to identify energized conductors. This can be useful in troubleshooting electrical circuits or in identifying the source of power in a system. When using a voltage tester to identify energized conductors, it is important to follow the manufacturer's instructions carefully and to take precautions to avoid contact with live parts. Furthermore, it is crucial to understand the difference between a voltage tester and a multimeter. A voltage tester is designed to simply indicate the presence or absence of voltage, while a multimeter can measure voltage, current, resistance, and other electrical parameters. While a voltage tester is sufficient for verifying the absence of voltage, a multimeter is necessary for more comprehensive electrical testing and troubleshooting. Regular inspection and maintenance of the voltage tester is also crucial. Check the device for any signs of damage, such as cracks or broken components. Ensure that the battery is in good condition and that the device is functioning properly. If any issues are detected, the tester should be replaced immediately. When working on electrical circuits, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. De-energize the circuit whenever possible before performing any work. If it is not possible to de-energize the circuit, take extra precautions to avoid contact with live parts. Remember that electrical safety is paramount. Using a voltage tester like the ChekVolt is an important step in ensuring a safe working environment. Always follow the manufacturer's instructions and take precautions to avoid electrical shock. In electrical work, the ChekVolt voltage tester and similar devices play a crucial role in confirming a zero-energy state. However, it is important to understand that these devices are part of a broader safety protocol. Establishing an electrically safe work condition involves a series of steps, including identifying all potential sources of energy, disconnecting them, locking out and tagging out the disconnecting means, verifying the disconnection with a voltage tester, and grounding the circuit if necessary. Lockout/tagout procedures are essential for preventing accidental re-energization of a circuit while work is being performed. These procedures involve placing a lock and tag on the disconnecting means, indicating that the circuit is out of service and should not be re-energized. Only the person who placed the lock and tag should be authorized to remove it. Grounding the circuit can provide an additional layer of protection by providing a low impedance path for fault current to flow in the event of accidental contact with a live part. This can help to trip a circuit breaker or fuse, de-energizing the circuit and preventing electrical shock. Furthermore, understanding the different types of voltage testers available is important for selecting the right tool for the job. In addition to non-contact voltage testers like the ChekVolt, there are also contact voltage testers which require direct contact with the conductors to measure voltage. Contact voltage testers typically provide more accurate voltage readings than non-contact testers, but they also pose a greater risk of electrical shock. Another type of voltage tester is a solenoid voltage tester, which uses a solenoid to indicate the presence of voltage. Solenoid voltage testers are known for their ruggedness and reliability, but they can be bulky and difficult to use in tight spaces. When selecting a voltage tester, consider the voltage range, accuracy, and features that are required for the application. Also, be sure to choose a tester that is certified by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. Proper training in the use of voltage testers is essential for ensuring safe work practices. Training should cover the principles of operation of the tester, the limitations of the tester, and the procedures for verifying the absence of voltage. It is also important to emphasize the importance of following safe work practices and using personal protective equipment. In addition to voltage testers, there are other types of electrical safety equipment that can be used to protect workers from electrical hazards. These include insulated gloves, safety glasses, and arc flash suits. Insulated gloves provide protection from electrical shock when working on energized circuits. Safety glasses protect the eyes from flying debris and arc flash. Arc flash suits provide protection from the heat and flames of an arc flash. Always use the appropriate personal protective equipment when working on electrical circuits. Also, regularly inspect electrical equipment for any signs of damage. Look for frayed wires, cracked insulation, and loose connections. Repair or replace any damaged equipment immediately. A well-maintained electrical system is a safer electrical system. In summary, the ChekVolt voltage tester is a valuable tool for verifying the absence of voltage in electrical circuits. However, it is important to understand the limitations of the tester and to follow safe work practices. Always use the appropriate personal protective equipment and regularly inspect electrical equipment for any signs of damage. Electrical safety is everyone's responsibility. In the context of electrical safety and voltage testing, several standards and regulations provide guidance and requirements for safe work practices. These standards are designed to protect workers from electrical hazards and to ensure that electrical equipment is installed and maintained in a safe manner. One of the most important standards for electrical safety is the National Electrical Code, or NEC, which is a widely adopted code in the United States for the safe installation of electrical wiring and equipment. The NEC contains detailed requirements for grounding, overcurrent protection, wiring methods, and other aspects of electrical safety. Another important standard is the National Fire Protection Association, or NFPA 70E, which provides guidance on electrical safety in the workplace. NFPA 70 covers topics such as hazard assessment, arc flash protection, and safe work practices. In addition to these national standards, there may also be state and local regulations that apply to electrical work. It is important to be familiar with all applicable standards and regulations before performing any electrical work. Understanding the concept of impedance is also crucial in electrical safety. Impedance is the total opposition to current flow in an AC circuit, and it includes both resistance and reactance. Resistance is the opposition to current flow due to the material of the conductor, while reactance is the opposition to current flow due to the inductance or capacitance of the circuit. A low impedance path to ground is essential for protecting against electrical shock. If a fault occurs in an electrical system, a low impedance path to ground will allow a large amount of current to flow, which will trip a circuit breaker or fuse and de-energize the circuit. Ground fault circuit interrupters, or GFCIs, are another important safety device that can protect against electrical shock. GFCIs are designed to detect small imbalances in current flow and to quickly de-energize the circuit if a ground fault is detected. GFCIs are commonly used in bathrooms, kitchens, and other areas where there is a risk of exposure to water. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in an electrical system. An arc flash can produce extremely high temperatures and intense light, which can cause severe burns and other injuries. Arc flash protection is an important aspect of electrical safety. Workers who are at risk of exposure to arc flash should wear appropriate personal protective equipment, such as arc flash suits and face shields. Performing a risk assessment before beginning any electrical work is also crucial. A risk assessment involves identifying potential hazards and evaluating the risks associated with those hazards. Based on the risk assessment, appropriate safety measures can be implemented to mitigate the risks. These measures may include energizing the circuit, using insulated tools, wearing personal protective equipment, and establishing a safe work zone. In conclusion, electrical safety is a complex and multifaceted topic. By understanding the principles of electrical safety, following safe work practices, and using appropriate safety equipment, it is possible to minimize the risk of electrical accident. The ChekVolt voltage tester is a valuable tool for verifying the absence of voltage, but it is only one component of a comprehensive electrical safety program. Always prioritize safety when working with electricity.